put on your bikinis and get ready to jump into 82-degree water. Now, ocean warming and ocean acidification are both really important coming events. In some ways they have already come, as you will see shortly. The red dots indicate where there are coral reefs around the world. You can see they hover either side of the equator. That's due in large part to the way the ocean currents circulate, so that you have warm water about 20 degrees either side of the equator. If that's not the case, you will find coral reefs. A few basics. These are wave-resistant structures dominated by a strong, rigid mass of living or once-living organisms, mainly the stony corals. Within about a 21-degree isotherm either side of the equator, biggest, most spectacular structures built by any kind of living organism. One thing you'll see when we get to a few slides and clips is that you don't see any plants. Here it's one of the most productive of all communities on Earth, right up there with kelp forests, salt marshes, tropical rainforests, and Iowa cornfields. All of those have just about the same amount of annual productivity, hugely productive systems. Now, it's a relatively tiny part of the ocean, less than 1% of the Earth, less than 2% of the area of the ocean, but very high in species diversity and high in economic significance. 375 billion annually to the world economy, guard the coastlines of 109 tropical countries. 25% of marine fish species live in this tiny part of the ocean on coral reefs. 10% of the diet, that's really important in tropical island countries where it's most of the protein for those populations. High in pharmaceutical resources. I'm going to take you to Fiji, which if you look at the east coast of Australia and then move to the right, I'm sorry I didn't bring a pointer, there's Fiji out there just east of Vanuatu. This is a typical what they call bommy. It's a reef in Fiji that's been growing upward since the last ice age. It comes near the surface from about 70 or 80 feet deep water. A coral reef at best reaches toward the surface at between 0.5 and 1 centimeter per year. So that bommy has been growing up as sea level has been rising since the last ice age. In other words, in about the last 10,000 years, corals have built that structure. And of course, it's all dead coral skeleton underneath. You just have this thin veneer of living coral material on top. Let's get a little closer to a coral reef. The rubbery-looking ones in the foreground to the right are the soft corals. The stony corals are the branching ones. They are the fastest growing. Some of those can grow 10 centimeters a year, 4 to 5 inches per year. But while the corals are growing and increasing the structure of the reef, fishes like triggerfishes, including that clown triggerfish, right there, chewing on the reef. Parrotfishes, even sea turtles are knocking down the reef at about the same rate it's growing. And then you get the periodic typhoons, hurricanes, and even less frequent tsunamis. And a shallow reef like this can literally get wiped out by the surge from those events. It's a fair thing to say that every coral reef in the world is recovering from the 100-year storm. Within 100 years, every one of these reef communities is going to get wiped clean and start over again. There you see a reef, and you ask yourself, all right, this is highly productive, so where the heck are the plants? They are in the corals. They're tiny little microscopic dinoflagellate algae called zooxanthellae. They're giving the color to those corals. That's where the photosynthesis is. That's where the productivity is. 80% of the living material in those animal coral colonies is the zooxanthellae, which raises the question, when a parrotfish eats live coral, is it an herbivore or a carnivore? It's actually both. So again, there is the color from the zooxanthellae, hard coral in the foreground, soft coral in back. Both of them have zooxanthellae. You'll notice that these fast-growing shallow water table corals shade out the competitors underneath them. There aren't any competing coral colonies growing under that table coral. That one's about the size of a cocktail table. It's probably no more than 30 years old. They grow quickly, but they have to because they're really susceptible to the storm surges. These are the first to go when a hurricane hits. The large mounding corals are much more resilient to storms, but they grow much more slowly. That one is about the size of a Volkswagen. It's probably several hundred years old. This one's the size of a single car garage. It's 30 feet tall. That's one coral colony. It's probably been growing there for about the last 5,000 years and has kept reaching toward the surface as sea level has been coming up from the last ice age. The soft corals are very colorful. Some of them have zooxanthellae, a lot of them don't. Even the giant clams, like the one there to the right, have zooxanthellae. That's how they get most of their nutrition, and it turns out they're very fast growers. This is a reef in Fiji we call Kansas. It looks like a field of waving wheat. It's all one species of soft coral, and again, zooxanthellae. So that's where the productivity is. Underneath there, it's really fascinating. Down among the trunks of the trees, all kinds of small species of fish live down in there. Get over the sides of the reef where there's less light, you get soft corals that do not have zooxanthellae. These are carnivores, and they feed mostly on plankton that is very tiny and in the water all the time, but it's so small that you don't see it. Or a few kinds of animal plankton that come up at night, but you don't see them during the day. Here are the critters that are breaking down the reef: triggerfishes, parrotfishes, even turtles. In this case, feeding on a soft coral. Soft corals aren't fed on anything else. They protect themselves with very nasty chemicals. But turtles are tough, and they also aren't the brightest candles in the chandelier. Okay. Just a few quick shots of the butterflies and insects of these very wet rainforests. Amazing species diversity, amazing colors. If these things have evolved different ways of competing with each other, or in this case, for the sea slugs, warning coloration, because these also taste bad. And that's why they're not bothered by the fishes. The bad news: 25% of the reefs have disappeared, 2/3 are at risk, 88% at risk in Southeast Asia. I don't know how many of you have ever snorkeled or dived in the Florida Keys. I started my diving career there back in the 60s. Since that time, 90% of the coral cover has disappeared in the Florida Keys. Some atmospheric CO2 basics. You all know most of this stuff. 2005 levels increased 0.6% over 2004 levels. Highest levels in the last 600,000 years. 136% increase since 1800. Will double the present value by the end of this century if we don't do something. Average global temperature in 2005 was 14.6 degrees centigrade. That needs updating. I think 2014 was the warmest year in history, was it not? Yes. Yeah. Okay. A 1 degree centigrade increase over 2000 level will result in catastrophic changes in sea level, species redistributions, and extinctions. Just 3 million years ago, the Earth was 3 degrees centigrade warmer than it is now, and sea level was 80 feet higher. If that were to happen, every major coastal city in the world would be seriously underwater. Okay, What does warming have to do with coral reefs? It stresses them, and so they become susceptible to disease, like white band disease there. Living coral above, the white band that's killing the coral, dead coral with filamentous algae growing on it below. Black band disease or sea fan disease. This is caused by an aspergillus fungus, similar to bread mold. It's there all the time. It's kind of like chickenpox virus in us. If we get stressed, maybe we get shingles. In the sea fans, they get stressed, this happens, or black band disease in corals. And then there's coral bleaching. Can happen if it's too warm, too much UV, too much sediment, too much fresh water, too much pollution, too much air exposure. Also, even if it's too cold. Most common cause of bleaching is elevated temperature. I'm going to scoot by this one. I happened to be in Fiji in 2002 during a major bleaching event. Here's what it looks like. If it's too high a temperature or too prolonged, the corals get rid of their zooxanthellae, they don't recover, and they die. Like this. That's a healthy table coral the size of a ping pong table. That's what it looks like when it's bleached or on the way to bleaching completely. That's what a whole reef can look like when more than 80% of the corals bleach, and the majority of those will not recover. Okay, now, that's one of the problems. This is a NOAA graphic from a month ago. Yellow means it's a coral bleaching watch. Red and dark red means it's already happening. There is a bleaching event going on in the Western Pacific now. They expect it's going to go all the way south to the Great Barrier Reef. Notice out there to the right of Australia, Fiji is right on the edge. In January, I'm going to be there next month. We'll see if it's starting to happen there. So that's the temperature problem. This is the ocean acidity problem. The CO2 blanket is not only raising the temperature of the ocean, it is also lowering the pH. The ocean isn't acid. It's not below the 7-point level of neutrality, but it's getting more acidic. And as it does, it makes it much more difficult for coccolithophores, forams, corals, mollusks, coral and algae, decapod crustaceans, fishes, anything with bones or shells has a much tougher time producing calcium carbonate and hanging on to it. If you don't know what a coccolithophore is, here is one. Now go home to your families tonight and say, hey, I'm really worried about the coccolithophores. See what kind of a reaction you get. These are tiny photosynthetic plankton in warm, temperate, and tropical oceans, mostly. Hugely important at the base of the food chain. Line 8 or 10 of these up and they would still be less than the diameter of a human hair. These are really tiny, but they're all over the place. How many of you know about the White Cliffs of Dover? Chalk cliffs. It's coccolithophores from an ancient seabed that has now been uplifted. So is the hill country in Texas. These are foraminiferans. They are little amoebas with calcareous shells. The one in the upper right looks kind of like a little mini chambered nautilus. This is a shot I took of a shrimp on a nudibranch's head. I didn't even know till I got it back and looked carefully. It's full of foraminiferans, that little tiny chambered nautilus thing sitting there. These are among the biggest amoebas in the world, and again, very important as food for lots of invertebrates and small fishes all over the world. Okay, now, who's having trouble with shells beyond coccolithophores and forams? Snails, bivalves, clams like the giant clam, big decapod crustaceans like crabs and lobsters and mantis shrimps. Even some of the worms, these Christmas tree worms, have calcareous shells. And fishes, they have bones. I'm going to leave you with one quote from a well-known zoologist back in the 19th century. This is not put out the way CCL would put it out. This is a little bit combative. It's those who know little and not those who know much who so positively assert that this or that problem will never be solved by science. Guess who said that? Good old Charles Darwin. By the way, I'll turn it over to Brendan right now. If you have a chance, pick up a book called Reef Madness. It's about Darwin and Louis Agassiz back in the 19th century battling each other over the origin of coral reefs. The science wasn't good enough to decide it definitively back then. It wasn't until we drilled at Eniwetok for the atom bomb tests in the 1950s that Darwin was finally proved right. I expect you could hear him cheering in his tomb when that happened. Now, take off your bikinis and put on down clothing because Brendan's going to take you to the high Arctic. Brendan,